Who's next, Stephanie?
Next, we have the World Poly Innovators on Abaji.
Hi everyone, I am Anabaja Raslanova. I am 14 years old. I'm in the 9th grade. I'm from Azerbaijan. 1 minute, share screen. I'm showing the innovation of device project in the Express. I am the CEO of World Poly Innovator Startup. Our solution is a new carbon dioxide to diamond device. Let's serve the world with a new device. The members of my team are from Azerbaijan, Rwanda, Oman, and Palestine. We have come together from different countries to save the world. We innovate to save the world. What's the cause of global problem? Carbon dioxide. Global problem, global warming. What's the global problem with carbon dioxide? Simulation machine, 1 minute. One minute. Sorry, internet connection problem. 1 minute. Simulation global machine on global warming. As you can see, sea levels are blue. Now all sides are green, plant and animal things are healthy. Let's start the machine. You can see sea levels are failing. Then there is global warming and the fish die. Every site turns into a desert. The plant world is being destroyed in order to avoid the problem of global warming. Global warming. How can we solve the problem of global warming? With our new device, we can solve problem of global warming. How does the device work? New carbon dioxide to diamond device. The device captures the gas from the atmosphere, freezes inside the device at -79°C. When frozen carbon turns into dry ice and it levels the atmosphere. Dry ice is collected in a special container below. On the other hand, the carbon-free atmosphere is released into the air. Let's look at the polyp simulation on this device. Carbon dioxide to diamond device, polyp simulations. The device captures the atmosphere. It attracts hydrogen gas, carbon dioxide, and oxygen gas. It then freezes inside the device at a temperature of minus 79 Celsius. Then nitrogen gas and oxygen gas come out on the other side. Carbon is converted into dry ice and stored in a special container. A machine is showing the project process. Project process machine. Indicators carbon retention, indicators the use of solar panels and wind energy for large device. Which special containers store the product in special containers? Profile products are made of special durable plastic or stainless steel with durable walls. An additional foam pad prevents heat from penetrating to the container and is kept at the ice oven temperature for some time. How does the device use minus 79 Celsius energy? The small device will run on battery. We use wind and solar energy only in our big device, which is in factories. When we say small device, what are the dimensions of the device? The dimensions of the device itself will be 45 centimeters, 70 centimeters, and 30 centimeters. The dimensions of the special container will be 30 centimeters on each side. The device removes 187 grams of carbon in 10 minutes. The device removes 1 kilogram, 126 grams of carbon per hour, cleans 27 kilograms of carbon per day. 100 million devices clean more than 1 gigaton of carbon. How will 100 million devices be used? Go to machine. Where will the device be used? The device can be used inside houses, on the outside wall of houses, in factories, enterprises. It will be used. A total of 100 million devices will be used. Houses will also use one device. 10 devices will be used in the enterprises. The device will be used 10 times larger form. Let's look at the simulation of the machine. This is the use of the device on the outside wall of the house. I did this to make our device interesting. I set up a STV simulation of our device. The device is her use of the device indoors. Enterprises. Use of the device in enterprises. 8 devices are used. Factory. This is the factory use of our device. The device is in big shape. Bring the accumulated carbon to a solid form, and we can keep it longer. chemical level. Dry ice simulation. What's dry ice? Dry ice is a solid form of carbon. Let's look at the simulations. Here red is oxygen and black is carbon. At minus 79 degrees Celsius, carbon dioxide turns into dry ice. Carbon dioxide, the molecular notation of both is the same. Dry ice. What do we do after this special container? I keep at the ice oven temperature for some time in every building that have the device for the dry ice that have been made by the device, and then every day a dry ice trucks will come to different neighborhoods to take the containers and pay money for the people who give the dry ice, and then special containers are transported to synthetic diamond factories. More income was obtained by turning dry ice into diamonds in diamond factories. How to make synthetic diamonds from dry ice factors? Chemical vapor deposition technology, high pressure, high temperature technology. Chemical vapor deposition technology, high pressure, high temperature technology. Why did we create such a project? New small process project, faster carbon cleaning, conservation of carbon into dry ice. What will this device give people? People will live healthier because the place where they live will be cleaned of carbon. Will take up little space and the territory will not be a problem. The device will be used to save the world because there will be no problem of global warming. When you take special container, dry ice machines will pay people a small amount of money instead, but factories run by dry ice machines will make more money by turning this dry ice into artificial diamonds. People will be given a small amount of money because artificial diamonds factories use the device to create dry ice and give it to the factory. Process follow diagram. Process follow diagram. Carbon dioxide diamond device process. The propagation of carbon in the atmosphere will decrease significantly every year to 1 gigaton, increasing the income of companies and individuals contributing to the decarbonization process using our efficient device, carbon dioxide diamond device.
And Abaji, this was fantastic. So how about we switch to the question and answer? Is that okay?
Yeah.
Okay. So Abaji, this was really fascinating, especially the simulations. These are, I haven't seen any detailed simulations like this, and use of all the libraries that other companies have made, from alphabetic library to the chemical library. To the library for solar. That was fascinating and amazing. So let's let Steven to go ahead. Steven, please go ahead.
Yeah, this is very impressive. Just curious, it seems to me like the device will take carbon dioxide from the air, and I guess even from the homes and the factories or the commercial spaces, and then it will freeze it to reduce the carbon dioxide, the carbon footprint. And that's how that seems to work. Is that right?
So Anabaji, you can unmute. Okay, so again, Steven,
Yeah.
It's a you know, Anabaji, first of all, I want to tell you that you did an amazing presentation.
Beautiful.
This is extremely hard. You did very, very, very good English.
Yes.
I'm very proud of what you did. And if I may, I'll answer instead of you, because you explained it. I'm saying what you said. You're right, Steven. They get that to dry ice, and then they train dry ice to diamond.
To diamond, right?
Yes.
And which is amazing. And not only that, it's a solution for a personal device, which I think is very exciting. I think it gives us this opportunity to even see the impact more clearly. I think sometimes we think we hear these big things about reducing carbon footprint, and we don't know what that means. Here, I think we can see the impact that we make, which is very exciting.
Yeah. And, you know, they did a lot of calculation for what does it, cost and how to do it. There have a lot of questions still, but in the submission they did to X Prize, they had much more detail that they put in place.
It's great. Wow, the world will be saved by this group of students.
Yeah, this is fantastic analogy. And you know, the type of simulations you had allows you to make an amazing 30-second video that makes kids excited to come. The most impressive one, I don't know how did you do it, and the math you put in place, but where the CO2s got together and dried into a structured crystal.
Yes.
Man, I don't know what's the math on that. I'd like to clone your machine and see how you did that.
Yeah.
But there's a lot of math going on to make this happen.
Great.
Okay. So Stephanie, can we stop here? And I know that there are other companies, NPS want to talk, but we are over time. Let's, NPS, can you be ready next week? You will present. And let's have Steven to talk for a few minutes and we do QA. We already got your time a lot, Steven. Sorry about that. Go ahead.
No problem. So did you want me to share?
If you have any thoughts, you want to share, especially about storytelling and how they do this better and most effectively, how they use these simulations and games to do that, that would be great if you share your ideas on that.
Yeah. Well, what I'll say, from both when I was teaching game design and also in my current position, storytelling is so essential to every area, right? So in games, it's so important that we have a narrative and a story that drives the game. Basically all games start with a very important story. The same applies, as you can see with what you're doing here, is you're telling that story people need the story for the context to understand. In the case of what you're doing, I think it's so incredibly important because we're taking these big ideas and we need people to be able to sort of see that in 30 seconds and understand it, right? So I think that's what has such an importance in what you're doing, because you're having to take all that information and say, how are we going to convey this information to the person who's watching our video so that they understand? I had, some of those questions I had, if the story in the video makes that, visual imprint on me that I'm like, I get it. That's, I think, what's so important about this. And, with that last presentation, I can envision a 30-second video that shows the device on the house, shows all the areas where the carbon dioxide is coming into the device, and shows maybe reduction. I don't know. I have an idea of like maybe you show minus signs with everywhere that we're reducing the carbon and showing it then be frozen here, and then that output going to make that diamond, and then, you know, a big sparkly diamond as the solution. I mean, something like that, that really captures all of this important information that you're conveying, you know, I think is so important. Similarly with the one, with the group, I think it was the group right before, where they're making the 3D, the avatars in PolyUp that people will be able to use with the dancing and the floss and these others. I can also see a video that gives people that idea that, hey, you know, you can make these, you know, animations to add to your projects or what have you. And I could just see that coming from the customizing maybe, or choosing the avatar and then showing where the math comes in. I mean, it's so important to bring that down to what people will understand. So I hope that is good feedback for what I take out of the importance of the story, especially in the context of what you're doing. We're looking a lot at using, you know, our tools like Unreal Engine as a storytelling tool, because anytime you use it to, you know, whether it be to make a simulation or to make a movie, you know, or a virtual production or a game or an immersive experience, it's all about that piece of it. You know, and I think what I had mentioned before about the metaverse is I think that's going to tie in where, you know, everybody's going to play a part in this greater, you know, global immersive community, and that's going to be at the heart of it. So, you know, I think it's really neat to see what you're doing with that. And I think that's such an important part of pitching or showing people what your product is about, you know, is conveying that message effectively and concisely.
Fantastic. That's great input. Let me share with you, Stephen, last week we talked about a set of painting from Picasso called Picasso Ball. And it's amazing that he starts from a complete ball and goes through 10 iteration and takes the details out. And the last one is like 5 lines. And you see the boldness of the ball rather than having all those details. And it's much easier to draw the whole ball with all details. And it's much harder to have like 5 lines that just says that. So
I see what you're saying. Yeah,
they're going through that process, and
yeah,
they're doing an amazing job of how to bring this down more and more, as you're saying, that the context be communicated and that 30 second. That's amazing. Fantastic.